So in this session we are going to discuss ferrous metals, a topic in Unit 1. The course is Mechanical Science and Engineering of first semester Automobile Engineering. In the last session you learnt various properties of metals. In this session we are going to discuss ferrous metals, cast iron, types of cast iron, alloy cast iron, effects of impurities on cast iron and wrought iron. Ferrous metals. The word ferrous is a Greek word for iron. The ferrous metals are those which have iron as their main constituent. So the iron is the main constituent in the metal. Such metals are called as ferrous metals. The ferrous metals commonly used in engineering practice are cast iron, wrought iron, steels and alloy steels. For any ferrous metal, the raw material is pig iron. So this pig iron, how to obtain this pig iron? We know that the iron ore is abundant in the earth crust and it is available in various forms. Magnetite chemical formula is Fe2O3 and it is black in color and it contains 72% of iron. Hematite is another iron ore. The chemical formula is Fe3O4 and it is red in color and it contains iron up to 70%. Limonite chemical formula is FeCO3 and its color is brown and the iron percentage is 65%. Siderite hydrated Fe2O3, color is brown and the iron content is 48%. Such iron ore is extracted from the iron mines and then it undergoes metallurgical process such as powdering and then washing that iron ore, and that powdered iron ore after washing, so it will be fed to the blast furnace from the top through gas tight valves, and this blast furnace contains coke bed and also over which a limestone bed. After filling the blast furnace with iron ore, hot air at 1000 degrees centigrade is passed through the blast furnace. This hot air at 1000 degrees centigrade burns the coke. When the coke is burnt, it produces large amount of heat up to 1500 degrees centigrade. At that temperature, this iron ore is melted and it will be melted to become molten iron. The limestone undergoes dissociation process, that is CaCO3 gives rise to CaO plus CO2. CaO is lime, so it is floating on the molten iron. So this floating lime along with it carries the other impurities which present in the iron ore. They will also be floated along with the lime over the molten iron. That slag is taken out separately. The molten iron is taken into molds known as pig. So that is why that iron is called as pig iron. Next, cast iron. So it is one of the ferrous metal. So its major constituent is iron only. This cast iron is obtained by remelting pig iron with coke and limestone in cupola furnace. So the pig iron is remelted in the cupola furnace with coke and limestone. Here any impurities present in the pig iron are removed and known quantity of carbon is added to the pig iron. Therefore, cast iron is an alloy of iron and carbon. The cast iron contains carbon 1.7% to 4.5%. So other constituents are silicon, manganese, phosphorus, sulfur. The carbon present in cast iron is in two forms, that is free carbon or graphite and combined carbon or cementite. Properties of cast iron. Cast iron is a brittle material. ಬ್ರಿಟಲ್ ಅಂದರೆ ಬ್ರೇಕ್ ಆಗುವಂಥ ಮೆಟೀರಿಯಲ್ಲು. ಯಾವಾಗ ಇಂಪ್ಯಾಕ್ಟ್ ಲೋಡ್ ಅಥವಾ ಶಾಕ್ ಲೋಡ್ ಬೀಳುತ್ತೋ ಅದು ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಇಟ್ ಕೆನಾಟ್ withstand shock loads or impact loads, and it is of low cost. It has good casting characteristics. Castings ಅಂದರೆ ಅಚ್ಚು ಹಾಕುವುದು ಅಂತ ಕನ್ನಡದಲ್ಲಿ. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಗುಡ್ ಕ್ಯಾಸ್ಟಿಂಗ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್. ಇದನ್ನು ಸುಲಭವಾಗಿ ಅಚ್ಚು ಹಾಕಬಹುದು. It has high compressive strength. It can take up compressive loads. It has high wear resistance. ಇದು ಸುಲಭವಾಗಿ ಸವಿಯುವುದಿಲ್ಲ. It has high wear resistance. It has excellent machinability. ಅಂದರೆ ಇದನ್ನು ಯಾವ ಶೇಪಿಗೆ ಬೇಕೋ ಅದನ್ನು ಮೆಷಿನಿಂಗ್ ಮಾಡ್ಬೋದು. ಬೈ ಯೂಸಿಂಗ್ ಸಮ್ ಮೆಷಿನಿಂಗ್ ಟೂಲ್ಸ್ ವಿ ಕ್ಯಾನ್ ಮೆಷಿನ್ ದ ಸರ್ಫೇಸ್ ಆ್ಯಂಡ್ ವಿ ಕ್ಯಾನ್ ಗಿವ್ ಶೇಪ್ ಅಂತ ಅರ್ಥ. The values of ultimate strength of cast iron are tensile strength up to 200 megapascals, from 100 to 200 megapascals, compressive strength 400 to 1000 megapascals. You can see it has high compressive strength. Shear strength 120 megapascals. Types of cast iron are grey cast iron, white cast iron, chilled cast iron, mottled cast iron, malleable cast iron, nodular or spheroidal graphite cast iron. Grey cast iron. The grey cast iron, its composition is carbon 3 to 3.5%, silicon 1 to 2.75%, manganese 0.4 to 1%, phosphorus 0.15 to 1%, sulfur is 0.0 to 0.15%, and the remaining is iron. So this is the constituent of grey cast iron. So here the remelted pig iron in the cupola furnace is cooled slowly, and it has 1 to 2.75% silicon. Due to the presence of silicon and due to the slow cooling of molten iron, the carbon is converted into free form. It is available in the form of free graphite flakes. Flakes means, you can see in this diagram, this is the microstructure of grey cast iron. You can see here the black needle-like structures. These are the graphite flakes. Because of these graphite flakes, fractures are present on the surface of grey cast iron and their color is grey. That is why it is called as grey cast iron. So it has grey color because of the carbon in the free form. It has low tensile strength. Free graphite present here acts as lubricant. So it has good wearing qualities. Idu free graphite, it acts as lubricant. That is why it has good wearing qualities. No ductility. So cast iron ನಾವು ವೈರ್ ಥರ ಎಳೆಯೋದಕ್ಕಾಗಲ್ಲ. It cannot be drawn into wires. No ductility. It has high compressive strength. So it can take up high compressive loads. So applications, it is grey cast iron used in making various machine parts such as machine tool bodies, automotive cylinder blocks, cylinder heads, flywheels, pipe fittings and any housings. Next is white cast iron. So this white cast iron is also obtained by remelting pig iron in the cupola furnace or any other electric furnaces like that. This white cast iron it also contains the following composition, that is carbon 1.75 to 2.3%, so slightly less compared to the carbon in grey cast iron. Silicon 0.85 to 1.2%, manganese less than 0.4%, phosphorus less than 0.2%, sulfur less than 0.12%, and remaining is iron. So here the remelted pig iron from the cupola furnace will be allowed for quick cooling. Because of quick cooling, the carbon present in the iron will be in combined form, that is iron carbide Fe3C. It is known as cementite. It is white in color. That is why this is called as white cast iron. So it is very hard. This iron carbide is very hard. And also you can find these black patches. It is of ferrite. Ferrite means layers of ferrite and cementite. So the iron is in carbon is in combined form, that is cementite. It is white in color. That is why it is white cast iron. It is because of quick cooling of the molten iron. Because carbon is not converted into free form, it is in combined form due to quick cooling of the molten iron. This white cast iron has high tensile strength, low compressive strength, it is very hard, it cannot be machined with ordinary cutting tools, so it requires grinding. The white cast iron may be produced by casting against metal chills. ಅಂದರೆ ಕೆಲವು ಕ್ಯಾಸ್ಟಿಂಗ್ಗಳಲ್ಲಿ ಮೆಟಲ್ ಪಾರ್ಟ್ಸ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾರೆ ಮೌಲ್ಡಿಂಗಲ್ಲಿ. ಮೆಟಲ್ ಈಸ್ ಗುಡ್ ಕಂಡಕ್ಟರ್ ಆಫ್ ಹೀಟ್. ಇಟ್ ಅಲೋಸ್ ದ ಮೌಲ್ಡ್ ಟು ಕೂಲ್ ವೆರಿ ಕ್ವಿಕ್ಲಿ ಅರೌಂಡ್ ದಟ್ ರೀಸನ್. ಎಲ್ಲಿ ಮೆಟಲ್ ಚಿಲ್ಸ್ನ ಪ್ಲೇಸ್ ಮಾಡಿರ್ತೀವಿ ಮೌಲ್ಡಲ್ಲಿ ಆ ರೀಸನ್ನಲ್ಲಿ ಬೇಗ ಕೂಲ್ ಆಗುತ್ತೆ ಮೌಲ್ಡು. ಯಾವಾಗ ಕ್ವಿಕ್ಕಾಗಿ ಕೂಲ್ ಆಗುತ್ತೋ ಆಗ ಆ ರೀಸನ್ನಲ್ಲಿ ವೈಟ್ ಕ್ಯಾಸ್ಟ್ ಐರನ್ನು ಫಾರಮ್ ಆಗುತ್ತೆ. ಸೊ ಚಿಲ್ಸ್ನ ಯೂಸ್ ಮಾಡಿದರೆ ನಮಗೆ ವೈಟ್ ಕ್ಯಾಸ್ಟ್ ಐರನ್ ಸಿಗುತ್ತೆ. ಅದರಿಂದ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಹಾರ್ಡ್ ಆ್ಯಂಡ್ ವೇರ್ ರೆಸಿಸ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಬೈ ದಟ್. ಸೊ ದಿಸ್ ವಿಲ್ ಬಿ ವೆರಿ ಯೂಸ್ಫುಲ್ for making some components such as ball mill liners, impellers, and then volute casing of slurry pumps and crusher rollers and all this. In making all these parts, all this requires hard surface, and in such cases it should be made of white cast iron, so we can get it by quick cooling of molten iron. Chilled cast iron. Chilled cast iron. So here the microstructure of this chilled cast iron is given. Here this is grey cast iron casting. In that, in one reason we have placed metal chills. That means it is allowed for quick cooling. And in the same molding, in this reason it is allowed for slow cooling. So slow cooling reason has grey cast iron only. Here carbon is in free form. It is in the graphite flakes. Carbon is in graphite flakes only. But in the other reason where quick cooling is provided by using metal chills, there the carbon is in combined form. It is in the form of cementite. So it appears white, and this reason will be very hard, whereas the above reason where slow cooling is taking place, this will be the reason. Here this is the grey cast iron reason, and here is the quick cooling reason. It will become very hard due to the presence of cementite, and this is white cast iron reason. So by using metal chills we can provide quick cooling of the molten iron. Due to that we are going to get chilled cast iron. So in a molding where in which region or which surface has to be hardened, in that cases we can place metal chills and we can harden that region by using metal chills. Mottled cast iron, it is the product between grey and white cast iron. malleable cast iron. So this malleable cast iron, it is more ductile, it has high tensile strength, it has excellent machining qualities. So this malleable cast iron we are going to get by providing heat treatment or annealing process to the white cast iron. When the white cast iron undergoes annealing process, annealing andre ಒಂದು heat treatment process, when the white cast iron undergoes this heat treatment process, then it will be converted into malleable cast iron, and at that time white cast iron, carbon in the white cast iron is separated into free graphite. So this malleable cast iron is used for making hubs of wagon wheels, railway rolling stocks, brake supports, agricultural machineries, pipe fittings, door hinges, locks, etc. So here some of the components of malleable cast iron are given here. So how to get malleable cast iron from white cast iron? There are two processes, white hot process and black hot process. In white hot process, the white iron castings are packed in steel boxes, and this iron casting is surrounded by a mixture of hematite ore, and then this box is heated from 900 to 950 degrees centigrade, and at this temperature the box is maintained for several days. At that time the carbon present in white iron casting is oxidized. Some of the carbon is oxidized out of the casting, and remaining carbon is dispersed in small specks throughout the structure. ಅದರೊಳಗೆಲ್ಲ ಸ್ಮಾಲ್ ಸ್ಪೆಕ್, ಸ್ಮಾಲ್ ಬಾಲ್ಸ್ ಥರ ಎಲ್ಲ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ. The cooling process takes several more days. It is allowed to cool for several days. This heat treatment results in casting which is tough and will stand hard treatment without fracture. This malleable cast iron is called as white hot malleable cast iron because of white color. Next one is black hot process. So here the white castings are used, it has less carbon and sulfur. This one will be packed in sand, and the reduction of sulfur helps to accelerate the process. That means here the combined carbon is converted to free carbon. It will be helpful due to the reduction of sulfur. ಸಲ್ಫರ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಬೇಗ ಕಂಬೈನ್ಡ್ ಕಾರ್ಬನ್ ಫ್ರೀ ಕಾರ್ಬನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ವೈಟ್ ಕ್ಯಾಸ್ಟ್ ಐರನ್ ಕ್ಯಾಸ್ಟಿಂಗ್ಸ್ ಆರ್ ಟೇಕನ್ ಇನ್ ಸ್ಯಾಂಡ್, sand packings, and this white cast iron casting is heated up to 850 to 900 degrees centigrade, and it is allowed to maintain at that temperature for 3 to 4 days. At that time the cementite is transformed into rosettes of temper carbon. Rosettes means the carbon will be combined together at one place to form rosettes, just like just like the shape of rose as shown here. Just like rose color shape, all the carbon particles are combined together to form these rosettes of free carbon. So the casting obtained by this process are more malleable, and it is somewhat black in color. That is why it is called as black hot malleable cast iron. Next one is nodular or spheroidal graphite cast iron. By adding a small amount 0.1 to 0.8% of magnesium to the molten grey iron, we are getting spheroidal graphite cast iron. Here the iron is converted to small nodules or spheroids. From the molten grey iron, carbon is converted into small nodules or spheroids. It has high fluidity, castability, tensile strength, toughness, wear resistance, pressure tightness, weldability and machinability. It is used for making hydraulic cylinders, cylinder heads, rolls for all rolling mill and centrifugally cast products, just like crankshaft, etc. Alloy cast iron. So this alloy cast iron is obtained by adding nickel, chromium, molybdenum, copper, manganese in sufficient quantities. So by this we can improve the properties. We can get increased strength, high wear resistance, corrosive resistance and also heat resistance. These alloy cast irons are extensively used for gears, automobile parts like cylinders, pistons, crankcase, crankshaft, camshaft, sprockets, wheels, brake drums and shoes, etc. Effects of impurities on cast iron. Silicon up to 4%. So the formation of free graphite which makes the iron soft and easily machinable. And then sulfur, it makes the cast iron hard and brittle. That's why it should be less than 0.1%. Manganese, it makes the cast iron white and hard. It is up to it below 0.75%. Phosphorus, it aids fusibility, fluidity in cast iron but induces brittleness. It rarely allowed to exceed 1%. Phosphor, sometimes it will be more than 1%, that's all. It should always be less than 1%. Wrought iron, it is the purest form of iron. It contains 99.5% to 99.9% of iron. All other percentages are very low compared to cast iron and other ferrous metals. Carbon 0.02%, silicon 0.12%, sulfur 0.018%, phosphorus 0.02% and slag is 0.07%. Wrought iron is obtained by remelting pig iron in the fuddling furnace of reverberatory type. So here the pig iron is remelted in open hearth furnace. That means here we are not using any coke or limestone. So it will be this wrought iron, this pig iron is remelted by using hot air only. That's why we are getting pure iron. So the pig iron is remelted by using hot air only. The pasty mass of iron and slag are mechanically worked by using mechanical hammers. The pasty mass of iron and slag is squeezed and then the slag is squeezed out. We are going to get pure iron and in the required commercial shape. So the properties of wrought iron, it is tough, malleable and ductile material. It cannot stand sudden and excessive shocks. It can be easily forged or welded. Its ultimate tensile strength is 250 megapascals to 500 megapascals. Ultimate compressive strength 300 megapascals. It is used for chains, crane hooks, railway couplings, water and steam pipes. Multiple choice questions. The ferrous metals are those which have iron as their main constituent. It does not contain copper, it does not contain zinc, it does not contain aluminium. Second question, pig iron which is obtained by smelting hematite. Hematite is the iron ore, bauxite is aluminium ore, bornite is copper ore, calamine is zinc ore. Third question, the cast iron is obtained by remelting dash with coke and limestone. By remelting pig iron with coke and limestone. Fourth question, cast iron is a brittle material. It is not soft, it is not light, it is not transparent. It is a brittle material. The carbon in grey cast iron is in the form of free graphite. The carbon in carbon in the grey cast iron is in the form of free graphite. It is in the form of graphite flakes. The carbon in white cast iron is in the form of iron carbide or cementite. It is in the form of cementite. Dash is obtained by quick cooling of the molten iron. White cast iron is obtained by quick cooling of the molten iron. Question number 8. Dash is obtained by adding small amount of magnesium to the molten grey iron. We are going to get spheroidal graphite cast iron. Magnesium has the property to combine together that carbon into spheroids shape. Spherical shape. Question number 9. Dash provides the formation of free graphite in cast iron. Silicon provides the formation of free graphite in cast iron. The wrought iron is produced by remelting pig iron. So thank you for watching this video.